Alright, welcome to Daily Coding Challenges. We're going to take a JavaScript challenge question from the internet and try to solve it. Today's question is pyramidSum. So write a function that takes in a base array of numbers. It should return a 2D array where every new array is the adjacent sum of the previous array, starting with the base. So the adjacent sum is the sum of the previous two elements of an array. Example 1, 2, 3, 4 will be 3, 5, 7 because 1 plus 2 equals 3, 2 plus 3 equals 5, and 3 plus 4 equals 7. So I guess on the flip side, this would be 5 plus 3 equals 8, and 5 plus 7 equals 12. Okay, so that shouldn't be too difficult. So let's go ahead and set this up. Function pyramidSum, and we're taking in an array. And I'm going to go ahead and set up a helper function for adjacent sum, and that is going to take in an array, and we'll say, okay, so it's the sum of the previous two elements of an array. Okay, so we'll say let sum array equal an empty array, and we'll set up a for loop. So for let I equal 0 while I is less than array.length, I plus equals 1, and we want to okay, so we want to add the current index plus the next index. So 1 plus 2 will become 3, 2 plus 3 will become 5, 3 plus 4 will become 7, 4 plus 5 will become 9. Okay, good thing I did that. As I was saying that, I was about to say 5 plus. Okay, so I'll need to make sure that it's not searching for a value after 5, or we're going to get a nan back, not a number. So the current index plus the current index plus 1. And we need to make sure it doesn't search for anything after 5. So let's say if I plus 1 is less than array.length, then we want to perform this functionality that we're about to write. So we'll say sum array dot push array at the current index plus array, it's going to be the typed out version, typed out full word, array at the current index plus 1. And I believe that should be it for that one. We will return some array at the end. So just checking over, so we got I array.length 5 plus plus. Okay, if the current index plus 1 is less than array.length, sum array.push array at the current index plus array at the current index plus 1. Okay, that should work. So up here we'll say function pyramidSum. So we want to perform this functionality, this adjacent sum, on this array, and we want that to create a new array. And at the end we need a 2D array with all these arrays. So we'll want this, the adjacent sum, to create a new array and put it in an array with this one. Then we want to run this function again on that new array that we created. So let's say we'll let pyramid equal an array with array inside of it. That'll be our starting point. So that's how I'm going to get my 2D array at the end. So we'll say, because we're just going to shovel each new array from this function, we'll push it into this outlying array, the overall array that this array is inside of now. So we'll say for let j equal 0, while j is less than pyramid.length. Actually, no, I don't want to do that. I'll say while pyramid.length is less than array.length, j++. And the reason I did that is right now pyramid.length obviously is 1. It's only got one array inside of it. Since it's an array with an array inside of it, it's only counting that full array as 1. And each array we add after that, it's going to count as 2, 3, 4. So since we know we're going to be running this adjacent sum, basically however many times there are numbers here, so we'll run it once and it'll give us 3, 5, 7, 9, and 3, 5, 7, 9. We'll see it printed out then, so we'll show you what I'm talking about. So we'll say let, okay, this is where the fun starts. So pyramid, okay, so we want to take adjacent sum of the previous array, start on the base. So we just want to run adjacent sum on each new array that we create. So I'm going to create a little roundabout here. We'll say let the previous level equal pyramid at the 0 index, and we will let the next level equal the adjacent sum of the previous level, and we are going to unshift. So we'll say pyramid dot unshift next level. And what's happening there is each time we go through this for loop, previous level is going to be pyramid at the 0 index. So starting off, this base array is the 0 index, because this whole array it's one item inside of this overall array. So this will be the 0 index on the first go around. So next level is going to be the adjacent sum of the previous level, which on the first go around the previous level is the base array. And then we are going to unshift next level to the beginning of the array, because unshift adds your item to the beginning of the array, so the 0 index. And on the next go around, the 0 index is that new array from the last go around. So we'll just keep performing this adjacent sum functionality each time we go around. And at the end, we should be left with the final array should be an array with just one number. Because when it gets down to 2, like say if 4 and 5 are left, the last array would just be a 9. And down here, I plus 1 would not be less than array.length, because in that case array length would be 1. So it would never perform this functionality, and the whole thing's going to stop. So let's return pyramid, and we will run this and see what we get. So I figured there was going to be a lot of numbers in the return. That's why I added these in between, just to make it a little bit easier to see. So we'll pull this up. So on the first one, our base array was 1, 2, 3, 4, 5. So the 1 and the 2 became 3, 2 and the 3 became 5, 3, 4 became 7, 4, 5 became 9. And continuing, 3 and 5 became 8, 5 and 7 became 12, 7 and 9 became 16, 8 and 12 became 20, 12 and 16 became 28, and 20 and 28 became 48. So it worked there. So let's check these double digit and triple digit numbers and just see. Oh, that's going to be a lot of math, but I think we can do it. So the 20 and the 40 became 60, 40 and 60 became 100, 60 and 80 became 140, 180 became 180, 120 and 100 became 220, 120 and 140 became 260, and 140 and 160 became 300. Okay, there's no reason to keep going up because it looks like it's working. I'll just check one of the last ones here to make sure these big numbers are working. So let's check. Actually, let's check the very last one. So 5120 and 6400. So 5 and 6, 11, and then 520. So 11, 520. So that works. So this should be a solve. Alright, so I guess that is it for this one. If you have any questions over anything that I did, drop it down in the comments and I will try to help you out if I can. If I don't get to your question, hopefully somebody else in the comments will help you out. But I will try to help you out if I see your question. And I'll catch you next time.